Okay, in this video we're going to be solving this system by using matrices. Now we're only going to go as far as writing the system in row echelon form. So just to remind you what row echelon form looks like, it is a matrix, an augmented matrix, in which the diagonals are all ones. Now I'm just using letters A, B, C, D, E, and F to indicate real numbers. They could represent any numbers, but the diagonals must be all ones. And then from this we're going to be able to come up with a new system of equations which is equivalent to the original system, and we'll be able to back substitute. Okay, so that's the goal, is row echelon form. Notice where the zeros are. The zeros are in this corner right here. Okay, so we need to make zeros right here. So we need zeros, which means we need to eliminate. Okay, I'm going to erase what I just drew right there. But that's where those are the ones we need to eliminate. So the I just used the word eliminate, and the matrix method is really the elimination method. Okay, so I'm first going to write the augmented matrix. And what we do is we just write the coefficients. I'm going to put my line in a minute as soon as I get done writing all these coefficients. Notice the first column are the coefficients of x. The second column are the coefficients of y, and the third column are the coefficients of z, and then the last column on the other side of that line that I drew are the constants on the other side. Okay, so the order I like to do this in is to first try to get a 0 here, second try to get a 0 here, third try to get a 0 here. So you do it in that order. Okay, now I'm going to keep writing this matrix over and over and over and over and over again. Alright, so I need to make that 2 a 0. So I'm going to use rows 1 and rows 2. So I'll show you, my work's going to be done over here. Row 1 is 3, 2, negative 3, negative 2. Row 2 is 2, negative 5, 2, negative 2. Alright, it is not possible. Well, let me backtrack. If you can get a leading coefficient, an x coefficient of 1, you should put that row immediately to the top. We don't have that luxury, so we're not going to be able to do that. You could actually divide that first row by 3s across the board, but then you're working with a lot of fractions. So I'm actually going to change that initial 3 in that top left-hand corner. I'm going to change that to a 1 at the very end. It's a little different than the standard way of doing this, but it works a little bit easier, I believe. So I need 6 and negative 6. So I'm going to get the negative 6 there and the positive 6 here. So I'm multiplying these. It's just like the elimination method, except you don't use any of the variables. So I'm going to distribute this negative 2. And as a result, I get negative 6, negative 4, 6, 4. Now I'm going to distribute this 3. And as a result, I get positive 6, negative 15, positive 6, negative 6. I'm going to add these together. And as a result, I get 0, negative 19, 12, negative 2. Alright, I'm going to replace row 2 in my matrix with this result. So when I rewrite the matrix, just write the first row in the original format. Now write the second row in your new format. You didn't do anything with the third row, so keep that the way it is. Draw your line and draw that. Okay, now we have a new challenge ahead of us. Let me just fix this. Alright, great. Okay, now I want to use the first row, 3, 2, -3, -2, and row 3, 4, -3, 4, 10. And I want a 0 where the 4 is. Okay, so what I'm going to do is I have to multiply both of these. I'm going to multiply this first one by -4 and the second one by 3. Now as a result, I get -12, -8, +12, +8. I just distributed the -4. Now I'm going to distribute the 3, and I get, as a result, 12, -9, 12, 30. Add these together. 0, -17, 24, 38. So when I do this, I'm just adding each column. Now I'm going to replace row 3 with that result. So keep row 1 the way it is. Keep row 2 the way it is. Now replace row 3 with the result you just obtained. Put your line in, close it. Okay, we're looking good so far. Now we need to get rid of that -17. We need a 0 in that location. Okay, some people will tell you that you should now divide each entry in row 2 by -19 to get a resulting 1 there. The way I do it eliminates the use of fractions. I don't know if you'd appreciate that or not, but I know that I don't really like to work with fractions, so it eliminates that result. Now we're going to use rows 2 and 3. So I'm going to copy down rows 2 and 3. 0, -19, 12, -2. That's row 2. Now row 3. 0, -17, 24, and 38. Okay, we're going to end up with some big numbers here, but that's okay. I need to eliminate that -17. So I need a 0 there. That means I need opposite coefficients. I currently have a -19 and a -17 in that second column. 19 and 17 are both prime numbers. So I'm going to multiply the first row that I have by +17. Then I'm going to multiply the next one by -19. Okay, a +17 times the -19 will result in a negative value. The -19 times the -17 will result in a positive value. So just watch what happens here. 17 times 0, 0. Now that's the beauty of getting rid of those x coefficients first and getting 2 zeros in that first column, because now no matter what you multiply, it's going to be a 0. So that will remain 0, which is really nice. 17 times -19 is -323. 17 times 12, 204. 17 times -2, -34. -19 times 0, 0. So now I'm working on the second equation. -19 times -17, +323. See, those will go away. -19 times 24, -456. -19 times 38, -722. Okay, I did not do those in my head. I did those with a calculator earlier on. So you can pause and verify that those calculations are correct. Use a calculator to help you work this out. Okay, add these two together. First column, 0. Second column, 0. Next column, negative 252. Last column, negative 756 when you add those columns. Alright, right now, it would be ideal to divide each of these terms by negative 252. Just to simplify, we're going to see if we can get a 1 where that negative 252 is right now. Okay, this results in 0, 0, 1, and negative 756 divided by negative 252 is 3. Alright, that's what we're going to replace row 3 with. So here's where we were, in the upper left-hand corner of your screen. Rows 1 and 2 will stay the same. Row 3 is going to get replaced with what we just found. Okay. So rewriting our matrix, row 1 stays 3, 2, negative 3, negative 2. Row 2 remains 0, negative 19, 12, negative 2. And row 3 now becomes 0, 0, 1, 3. Now, if you are not worried about obtaining row echelon form, you are ready to back substitute right now. Okay, but we want to get row echelon form. So I'm going to do all these within this matrix here. Row 2, I'm going to divide each of those by negative 19. Row 1, I'm going to divide each of those by 3. The result is 1, 2/3, negative 1, negative 2/3. 0, 1, negative 12/19, 2/19. 0, 0, 1, 3. This is row echelon form. Okay, now we need to back substitute. So from this, we get a system of equations that says x plus 2/3 y minus z equals negative 2/3. Y minus 12/19 z equals 2/19. And z equals 3. Okay, now we know z equals 3. So we're going to substitute 3 in the equation right above it. And we get y minus 36 over 19 equal to 2 over 19. We will add 36 over 19 to both sides, and we get 38 over 19. We'll simplify, and we get y equals 2. We will now copy down the equation with 3 variables, which was x plus 2/3 y minus z equals negative 2/3. And we will substitute our answers for x and y. So x plus 2/3 times 2 minus 3 equals negative 2/3. X plus 4/3 minus 3 equals negative 2/3. Multiplying this whole equation by 3, we get 3x plus 4 minus 9 equals negative 2. Simplifying, 3x minus 5 equals negative 2. 3x equals 3. X equals 1. So the solution is 1, 2, 3. X is 1, y is 2,